In our last lesson, we were given graphs and we were asked to find out where the midline, amplitude, and period were for each of those. Now, today we're going to be working from equations. So for this one, notice we're starting with the parent function of sine. And we're being asked where this midline, amplitude, and period are. Hopefully, these are fairly familiar. The midline for sine of x is at 0. So it's going to be y equals 0 for that first part. The amplitude is 1 because by default, our midline and our amplitude are those values. Now, what is it by default, though, for the period? Well, remember the period is how long it takes to complete one full cycle. If I'm graphing sine of x, one full cycle takes us 360 degrees. That's where we start in the middle, and then we go top, middle, bottom, middle, and that last middle where we start repeating ourselves is over at 360 normally. Today, though, we're going to be tweaking that a little bit. And so here's our next equation that we're going to be working with, cosine of 2 theta. Well, the midline and the amplitude are unaffected by the 2. The 2 is actually going to be affecting the period. So if midline is unaffected, it's got to be at 0. If amplitude is unaffected, it's got to be a 1 because they're the same as the parent function. But now we need to be able to calculate what the period is. And for that, you're going to need to take some notes. So go ahead and take a moment, write all of this into your notes, and then we're going to see how to use it. Pause the video, and then press play again when you're ready to go. All right, so back to our problem here, y equals 2 cosine of 2 theta. In order to find the period then, I'm going to have to do what my notes just tell me to do. I'm going to have to do 360 divided by that b value, which is 2. So I'm going to do 360 divided by 2, which gives me 180 degrees. Now to give a little bit more detail, here's a little bit more notes to put down. So again, take a moment, pause it, put this into your notes, because it just explains a little bit more detail how that 2 is working here. Because notice what the 2 does. The 2 means that we complete 2 cycles between 0 and 360. All right, so now that we've seen what the midline, amplitude, and period are for this equation, now let's see how we'd go about graphing it. So first up, the midline, it is at 0. And then my amplitude is 1, so I'm going to go up 1, and I'm going to go down 1. The difference in this graph, though, is the spacing horizontally. That is how far we go over to put each point. Because normally, I'd start at the top, and then my next point would be at the middle at 90, but it's not going to be there. Because the 2, remember, makes this half as wide. And so instead of going over 90 degrees from our next point, I'm going to go over half as far, which is 45 degrees. And then 90, and then 135, and then 180. The idea of what the 2 is doing is it's saying that I'm going to need to be able to fit 2 of these cycles onto the same graph. So notice here, when I extend that out to 360 degrees, I end up with 2 full cycles here. The upshot of that then is that each time I put a point in, instead of going over 90, I'm going over half as far. That way I can actually squish 2 of them onto the same set of axes. So this is our graph of y equals cosine of 2 theta. Now, having seen how to do that, though, we're going to do a second graph of y equals cosine of 2 theta. Because there's 2 different ways we can approach this. One is we're working from the same old scale that we've always been given. We're going out to 360, but sometimes if we're setting up the scale ourselves on paper, we can actually do this a bit easier. Remember where we're putting every point. We were not putting a point every 90 degrees. We were putting a point half that. We were putting points at every 45 degrees. So I'm going to go 45, and I'm just going to count by 45s going up this scale. By doing that, I've changed the labels of my scale here, but otherwise I can make my cosine graph like I always do, because it starts at the top, and then at the middle, just notice here that middle is at 45 degrees, but I spaced it out so that they're more where I typically see them. This is the exact same graph that we just made. The only difference is that instead of going out to 360, we went out to 180. So we graphed one complete cycle of it. All right. Now, let's see what happens when the equations start getting a little bit more complicated. So here we have -3 times sine of 2x plus 1. First up, we need to figure out where the midline, amplitude, and period are. So the midline, remember the midline is whatever number is added or subtracted onto the end. In this case, that is 1. So our midline is y equals 1. Amplitude, that's whatever number is multiplied out front. Always positive, though, because it's a distance. So in this case, my amplitude is 3. And then the period is determined by this number. The 2 is not the period. The 2 tells me how to calculate the period, because I still have to do 360 divided by 2. The 2 is technically called the frequency. It's telling us how many waves I complete in the normal 360 degrees. So again, if I do 360 divided by 2, that gives me 180 degrees for my period. Now, knowing that information then allows me to make the graph. So if I now look and see how to make the graph for this, the first thing I'm going to do is draw the midline and the amplitude. So my midline's at 1, and then I'm going up 3 and down 3 from there. Now I can start plotting points. Sine starts in the middle. Now notice though, this is not just sine, this is negative sine, which still starts in the middle, but then instead of going up, negative sine is actually going to start by going down. So I'm going to be going down next. My next point goes on the bottom. The question is where on the bottom? Because it's not going to go at 90 in this case. The 2, remember, is squishing this graph down. It's squishing it so that I need to be able to complete 2 full cycles between 0 and 360. And so instead of putting a point every 90, I'm going to put the point every 45 degrees. Once I have that first cycle drawn in like that, then I can go ahead and finish making the graph, because I'm just going to continue that same pattern. I just at the middle, picking up from where I'm repeating from, it's then going to be bottom, middle, top, middle, and so on. And so then this is what our graph would look like between 0 and 360.